All right, hey, sixth graders. This is Mr. Gillis coming to you with another video tutorial on 2.5. I'm going to try a little bit different today. So if it looks different, I'm just trying something new here. You can let me know if you like it or don't like it. I appreciate any feedback that you'll give me. But let's try it out here and see how it works. So today's lesson objective is to solve whole number addition equations, okay? Solve whole number addition equations. So here's probably more or less what you think about when you hear algebra as solving for these equations or solving for a letter, okay? I don't think it's that tricky of a process, but we'll get lots of practice with it because it might be the first time you've seen it. And I can promise you, you just need practice. I can remember the first time I saw algebra, I was terrible at it, okay? So don't feel bad. I might seem like I understand it now, but at first, holy cow, was it tricky for me. It took me probably a whole year to get better at it. I'm not going to lie. So I'm definitely willing to help you out here. I know how tricky it can be. All right, to start, let's discuss a little bit of vocab. And our first vocabulary word is inverse operations, okay? Inverse operations are operations that undo each other. Okay, so for example, an example of inverse operations would be addition and subtraction. Okay, some people call these opposite operations. Okay, the other set of inverse operations would be multiplication and division. These are also inverse operations. They undo each other. So it would be like if I had 5 plus 1 to give me 6. Okay. Actually, that's not a good example. I'll come back to that, okay? I'll show you kind of what it looks like in the examples. All right. So the first example says solve each equation and check your answers. All right. For letter A, it's x plus 87 equals 152. All right. The question you should be asking yourself is, what number plus 87 would give me 152? That's what I'm trying to find. What number, when I add it to 87, would give me 152? That's kind of the objective. The way we go about solving these types of problems is by using the inverse operation. Okay, so right away I see that I have x plus 87. If I wanted to isolate my variable, let's write that down. Isolate variable. What does that mean? If I'm going to isolate something, well, it means to get it alone. Okay, if I'm isolated, I'm alone. So I want to get x all alone so I can figure out what my answer is. All right. The other kind of useful thing that I like to do is I like to split my equation at the equal sign. So I have a left side and I have a right side. Okay. I can see that on my left-hand side, x is being added to 87. So to isolate my variable or to just get x all alone, I need to do the inverse operation. So what you need to ask yourself is, what is the opposite of adding 87? Okay, well, the opposite of adding is subtracting. Okay, so that goes in the box here. Subtract 87 from both sides to undo the addition. Okay. Whatever you do to one side of the equation, so we did it here, you have to do to the other side of the equation. So remember, an equation is like a scale. Okay, and when you balance out your scale, you have to either add something to both sides or subtract something to both sides to make sure that your scale is level. Okay, so if I were to do that, if I were to take 152 and subtract 87, what would I get? 152 minus 87. Okay, 2 minus 7, I can't do that. I'll borrow. That'll become a 4, and that'll become a 12. 12 minus 7 would give me 5, and 14 minus 8 would give me 6. So x would be equal to 65. Okay, now it says check that. Let's make sure that that makes sense. Let's substitute 65 for x and see if that makes my equation true. Well, 65 plus 87 would give me 152. Does 152 equal 152? Yes, it does. So 65 is our solution. Whew. Okay, kind of a lot that I threw at you there in a short amount of time. So some big words. Like I said, we'll get a lot of practice. So don't worry if that sounded really confusing. We'll try another one. Let me scroll down a little bit here. And let's try letter B together as well. Okay. Okay. For letter B, it says 72 equals 18 plus y. All right. So what I'm trying to think about now is what number, when I add 18, would give me 72. Okay. So again, I'm going to split my equation at the equal sign. I'm just going to write it out over here. 72 equals 18 plus y. I like to split it at the equal sign because now it's like my scale. I've got the left-hand side and I've got the right-hand side to my scale. Remember, like before, we need to use the inverse operation to be able to solve this. So right now, y is being added by 18. So the opposite of adding 18 would be subtracting 18. Okay, so that will go in the box here, subtract 18 from both sides to undo the addition. Okay, so over here, 18 minus 18 cancels out, because 18 minus 18 is just 0. So 0 plus y, I don't need to write that. I can just have y equals, well, remember if I subtract 18 from the right, I have to do that to the other side as well because I need to balance out my scale. So 72 minus 18, I got to borrow. 12 minus 8 is 4, and 6 minus 1 is 5. So y would equal 54. Okay, let's check and see in this if that makes this equation true. Substitute in 54 for y. All right, so right here's y. I'd substitute in 54. 54 plus 8 is 18. Does that give me 72? Yes, it does. So 54 is the solution. Okay, wonderful. Let's next go to the back side and take a look at example 2. Whoops, I clicked on the wrong thing. I'm looking for screen sketch. There we go. It says Johnstown, Cooperstown, and Springfield are located in that order in a straight line along the highway. It is 12 miles from Johnstown to Cooperstown and 95 miles from Johnstown to Springfield. Find the distance d between Cooperstown and Springfield. Okay, kind of a mouthful there, but maybe if you draw it out, it would kind of help you. So let's pick a new color here. Let's do this. All right. Coming back here. Again, I want to just illustrate this. So I've got Johnstown, Cooperstown, and Springfield in that order. Okay. It's 12 miles from Johnstown to Cooperstown. So from here to here is 12 miles. And from Johnstown to Cooperstown, and 95 miles from Johnstown to Springfield. Okay, here we go. So from here to here, it's 95. All right. Find the distance between Cooperstown and Springfield. So here to here is what we're calling D. All right. So if we take our distance between Johnstown and Springfield right here, and we say that needs to equal the distance between Johnstown and Cooperstown plus the distance between Cooperstown and Springfield. Yeah, this distance plus this distance should be the same as this entire distance up here. Okay, so we just wrote that out into the equation. 95 equals 12 plus D. All right, let's write that. 95 equals 12 plus D. So what I'm looking for is what number added to 12 will give me 95. All right, let's split our equation at the equal sign and be thinking about the inverse. How do I get D isolated? How do I get it all alone? Well, I see that it's being added by 12. So to undo that, I would subtract 12 on both sides of my equation. 12 minus 12 is 0. Perfect. That just leaves me with D equals, and just do a little subtraction here. 95 minus 12, 5 minus 12 is 3, 9 minus 1 is 8. Okay, let's fill in my blanks here then. So again, I needed to subtract 12 from both sides to undo the addition. And I got a total of 83. It is 83 miles from Cooperstown to Springfield. All right, awesome. Let's go to the last part, the check it outs for 1 and 2. Why don't you go ahead and pause your videos here and try it on your own and see what you come up with. All right, I'll work out these two and hopefully you came up with something similar. First one, U plus 43 equals 78. Split it at the equal sign. What number plus 43 will give me 78? Well, to isolate my U, I see that's being added by 43. To do the inverse would be to subtract 43 on both sides of my equation to keep my scale balanced. 43 minus 43 is 0. It cancels out. Wonderful. Be left with U equals 8 minus 3 is 5, and 7 minus 4 is 3. 35. Box my answer. Okay. And for number 2, we have one that's very similar to the last one. It says Patterson and Jacobsville and East Valley are located in that order. 17 miles from Patterson to Jacobsville, so 17 from here to here. 35 miles from Patterson to East Valley, so Patterson to East Valley is 35 miles. Find the distance between Jacobsville and East Valley, so distance D between the two. Let's set it up to like we did our last problem. So I had started with my total, but I'm just going to move over here, which was 35 miles total. That equaled my next two added together. So that was 17 plus D. Okay. Well, I'll split my equation in half here. D is being added by 17. So to undo that, I'll subtract 17 on both sides. 17 minus 17 is 0. Perfect. I've isolated D, and I just need to do some subtraction. 5 minus 7, I can't do. I'll borrow. 15 minus 7 is 8, and 2 minus 1 is 1. So I get 18, and my label would be miles. Okay. And that does it, guys. That's an introduction to solving these algebraic equations using addition. And actually, to solve them, we use subtraction. So keep practicing. Don't be disappointed if you don't get it. It takes a while. Trust me on that. Thanks for tuning in, and we'll see you next time.